All right, thank you so much for having me. We're here today to talk about ScopedModel, so let's build up the hype, right? We're talking about ScopedModel. We're not talking about block today. We're not talking about MobX. We're not talking about Redux. We're talking about ScopedModel, all right? Yeah, hype it up. So this is the one state management solution you will ever need. Just joking, just joking. But really, what I want to talk about is ScopedModel. I want to talk about architecture. But really, what I would like to talk about is how you can understand ScopedModel by building ScopedModel. Oh no, are we coming through here? Oh, my computer got disconnected somehow? Oh, okay, sounds good. Cool. So basically what we're going to start with is what is ScopedModel. So ScopedModel is a library you can use to help architect your applications. And it's a really simple library that's actually based on really core Flutter tools, notably InheritedWidget and Listenables. So we're going to kind of go through how ScopedModel works, how it fits into like maybe the picture of an architectural, and then we're going to kind of go ahead, live code, pray that those live coding gods are with us, and try to build ScopedModel in 20 or so minutes. So usually if you're just starting with Flutter and you're just getting used to the architectures, I wouldn't recommend jumping into block or ScopedModel or MobX. I really recommend you just start with stateful widgets and use setState to update your applications. And what's going to happen is eventually I think you'll see quite naturally that your stateful widgets become quite complex and that they start to be quite long, quite entangled. You have different things sort of mixed together in a single class. And usually at that point, it's a good idea to consider refactoring. And so a pretty natural refactor, in my opinion, is to think about the responsibilities within this state class and to think about the single responsibility principle. So you might think about something like a login screen, and you might have a stateful widget backing up that login screen. So it's going to have some data, right, like the email and the password that you're storing, and then it's going to have maybe some business rules like, okay, is this a valid email or is this a valid password? And then finally, it's going to have maybe some data logic to it, right? Where it's actually, once the user taps on that login button, it's going to call some sort of backend. Maybe that's like Firebase, using Firebase to sign in, or maybe your own web server, or some sort of OAuth. Some sort of backend is going to be called. And so you're going to start to see that there's actually a lot of responsibilities contained within one class. And so what you can use is you can use a pattern of layering to go ahead and break your things up. And this is stuff that I've kind of talked about before, but I really want to kind of bring it home with how model fits into this. So what you can do is you can kind of leave your widgets like as they are, right? So the stateful widget itself is going to take that data and it's going to build a UI from it. So that part you can leave totally alone, and you can leave that in your widget layer. That's great. That's what the widgets are meant for. They're meant for taking data and turning it into a UI, and then when a user interacts with your UI, they do something with it. Then you can consider extracting some of the logic out into a model. And some people call this a presenter, some people call this a view model. With the model class, I'm just going to call it a model. And if you're familiar with clean architecture, this might be like a bastardized example, or like a smaller, like a fewer number of layers than you might be used to. And if that's triggering you, please don't let it. I'm just trying to simplify this a bit for people who are kind of getting into architectures for their first time. And then finally, you're going to have something like a data layer, right? So that part of your stateful widget that was actually talking to Firebase or talking to your backend, you can extract that out into its own class or its own function. And that will make, and you might be like wondering, okay, so like why would you do this? Okay, so if you were to jump into your state class at first, it might be like a couple hundred lines, it might be doing a lot of things, and it might be difficult to figure out. So when you refactor it like this, and if you use a kind of consistent pattern throughout your app, then it makes it actually much easier to navigate a large application, because you're like, all right, where's my widget getting this data from? Well, you can go look at the model or the data classes and just look at those to see like, okay, this is how it's actually happening. The other big thing is that this improves testability, and this is a really big one. Just from my background, I've generally worked on larger applications with lots of users, and frankly, new features are great, but if you break something when you're developing that new feature, it's probably going to cost you a lot more than the benefit you gained from a new feature. So testing your applications to make them robust is really big. And this is really nice as your application scales, because then you can have different parts tested as new people come in and work on them and they make modifications. They can know that when they make those changes, those tests are in place. They can run those tests to make sure that the changes they've made don't break them, and they can really quickly and confidently make changes. So when it comes to the model, it's actually a listenable. So this is a core class from Flutter. And so the way that these things communicate generally is that the widgets will call functions that the model provides. The model will process that data. It might talk to the data layer if it needs to be. And then it'll send that data back up to the widget layer. And the widget layer can listen to changes on the model because it's a listenable class, and it will rebuild whenever that listener emits some sort of change. One question I get asked a lot is like, what is the difference between model and block and MobX? And to be honest with you, if you think about your architecture in this sort of simplified way, and actually I think if you think about your architecture just generally, I don't think there actually is that much, and this is kind of a side point, but I kind of think that models, like blocks, which communicate via sinks and streams, and like MobX stores, or Redux, like these things almost all sort of fit into the same part of the architecture diagram. So they kind of work in different ways, and there might be pros and cons to those implementations. But I think when you think about something like which one of these should I choose, the reason I would say listenables can be nice is for two reasons. Number one, they're baked into Flutter, and number two, they're very simple to use. So this is a question I get a lot as well, is like, hey, if RxDart and block exist, is like our scope models or models still actually useful? And my answer is yes, because a lot of people have struggled with how complex RxDart can be. And I think you can use Rx in a simple way, but it can also become very complex very quickly. And so scope models, or models in general, are a really nice way to sort of give you the benefits of a block without having quite so much complexity. The other thing you'll notice is that they're actually everywhere in Flutter. So you might have even used these things if you've been working with Flutter for a while. I'm sure you've used animations. You've probably maybe even like hooked into a scroll controller. You might have used a text editing controller or a tab controller. Anything controller is probably some sort of listenable or exposes data as a listenable. So you might already be using these everywhere, and you might just not notice it. Or yeah, you might just be unaware that these are all listenables. And as I said, they're quite simple overall, or hopefully, like, I don't want to say that because in case you don't understand it, don't feel bad, but like, essentially, there's not a lot of magic happening with them. So you start, so we'll have a counter model, and it's going to extend the model class, which will provide the ability to listen to it. And then what we'll do is we'll just have some data, so a count. So this is pretty similar to the counter example you've seen in the past. We'll have a public method to get the count because we don't want people to directly modify that. And then we'll have a method called increment, and this will do two things. First, it will increment the counter, and then it'll say, hey, notify the listeners. And this will basically say if there are any listeners that are listening to this model, they'll actually run a callback function, and you can provide any callback function you'd like. So a usage example, you don't have to use ScopedModel directly in Flutter. You could actually just, with a widget tree, you could actually just go ahead and instantiate the model. You can print the current count. Then you can add a listener. And in this case, it's just going to take a function. And as I said, every time we call notify listeners, it's going to run this function. So if we were to call the counter.increment, then it would actually increment the counter, notify the listeners, and therefore it would run this function which prints 1. So that's like kind of how you would use them independent of Flutter. And I just wanted to let you know that because like there are many cases where you're actually going to need to hook your own listeners onto listenables in general. And this is sort of the standard way to do it, whether it's a model or a change notifier or a text editing controller, etc. So then with Flutter, you've got a couple of different ways to do it. So then you can instantiate the model. And this is a question I was asked as well, is like, where do you instantiate scope models? So, if you only need to instantiate the model at the top level, you can just instantiate it directly in your main function. I generally don't recommend this. Usually what I try to do is I try to create a model on the screen or the widget that needs it, and only at that point. So I usually try to avoid creating too many models like at the top level of my application, even though ScopedModel makes this very easy. Because usually you only want to have your models instantiated and destroyed when the screens or widgets that need them are created and destroyed. So just trying to tie your life cycle of your model to a stateful widget. So in this case, to look at that, what you might have is a state class, and then you would instantiate the counter model. Oh, I guess I didn't do that in this example. And then when the widget is disposed, you would dispose of the model. So this is usually the way I would personally instantiate them. And this, like I said, allows you to ensure that a model doesn't live for longer than it needs to. And this is actually, once again, the same advice I would give for blocks or a MobX store, et cetera. You know, it's a really good idea to think about how long your object should live. And if they are really closely tied to the widget's life cycle, then allow the widget to create them and destroy them as it's created and destroyed. Now, if you have this model, it's a listenable. And so this is where things get, a little bit interesting. So now what you want to do is you actually want to listen to this model, and whenever it notifies, instead of just adding a listener and printing it, which is not very exciting, we want to create a widget, a new version of a widget, new instance of a widget every time that model changes. So in this case, you can actually use an animated builder. Now this sounds kind of crazy, it blew my mind when I discovered this as well. And it might be kind of a weird hack, but animated builder actually, even though it says it takes an animation, it takes any listenable. And so I kind of wonder if this should be renamed to something like a listenable builder. But what you can do is it works in this way: is you say, okay, give me an animated builder. I'm going to hand you a listenable. And when this listenable changes, go ahead and run this builder function to create a new widget. And this is really nice. So now that anytime that increment is run, we can use animated builder and hook onto it and rebuild. So this is using just the model class by itself. And so there are sort of two parts to ScopedModel. The first part is the model class, which we just described and talked about. And this is really just a simple class that allows you to listen to it and respond to changes. And that's about all it does. And then the second part comes when you have a more complex widget hierarchy. So I think I've showed things like this in the past, but basically the idea is that maybe you're holding this model in the stateful widget at the top of the tree, and you have a fairly complex widget tree. And you might be wanting to pass this counter down the widget tree further and further. So the traditional way you do that is just by passing the counter to this widget, then to the next widget, and finally to maybe a text widget where you're going to extract the counter.count and wrap that in an animated builder so it's rebuilding whenever it changes. And then on the other side, maybe you want to pass the counter down to another widget, and then it can use that to render a button. And when someone taps on that button, it will call the increment method on your counter. So the issue with this is that, say if your widget tree changes, then you actually need to remove a lot of this plumbing, and it gets a little bit messy. So, oh yeah, and of course when you tap on this thing, we want that to rebuild. So how can we solve that problem? And so ScopedModel provides another class. Actually, this is actually a widget. So the model itself is not a widget. It's just, everything's not a widget, actually. So it's just a class itself that is really easy to test in isolation. But then you have the ScopedModel widget, which will take any model that you give it, and it'll pass that model down the tree for you. And then you can access that model. So this kind of looks like this, where you have a ScopedModel widget, and you have to parameterize it so it knows what kind of model you're giving it. In this case, we'll just provide it the counter, and then we'll give it a child. And then within the child, you can access the ScopedModel in a couple of different ways. The first way is you can use the ScopedModel.of method, and this will look up the widget tree for the ScopedModel that you're interested in, and it will find the model associated with that. And then you can use that to build your counter. And to be honest with you, this is actually a really nice way of providing access to your model, and especially if you need to maybe get 2 or 3 models within a single build method, rather than having some crazy wrapping, you can just use the ScopedModel.of method. But there's an interesting thing is that ScopedModel provides another way to get the model, and that's this ScopedModel descendant class widget, actually. And this is a total mouthful, but basically what it will do is it will sort of do that process for you, where it will look up the tree and find it for you. And then anytime the ScopedModel changes, it'll run this builder function and create the new text for you. Okay, and actually under the hood, I said that this is using ScopedModel, but really the technology it's using is something called an inherited widget. And so this will be the second thing we really look at. All right, so let's live code and pray that this all goes according to plan. So we're going to code 3 things then in this this awesome workshop. We're going to code the model itself. We're going to code the ScopedModel Widget. And we're going to code the ScopedModel Descendant widget. And so hopefully by the end of that, we'll understand how model works, how the ScopedModel works, and what the actual difference is between ScopedModel.of and the ScopedModel Descendant. And the spoiler is there's not that much to it. So let's get into it. All right, so we're going to go ahead and create a new project. Flutter. Live scoped model. Done. Hopefully this creates. All right, so when we get this going, the first thing we'll want to create and start out with is the model class. As I said, the model class is actually kind of its own thing, and it works independently of the ScopedModel widget. You can use it entirely on its own. Yeah, for sure, sorry. All right. So, increase, actually, I think I need to do it in here, don't I? Editor, font, no color scheme. $24. How's that? Is that easy to see? Do I need to go white theme, or is this all right? Can people read this actually? Easy to read? All right, cool. So the first thing we're going to do is we're going to go TDD here. So we're going to create a file in the test folder, and we're going to call it model test. All right. So let's get our tests going. So we're going to go ahead and create a model group of tests, and let's go ahead and get our imports going. So we'll want to import Flutter test, and we'll essentially want to do 3 things. We want to allow people to add a listener, right, so that they can add a listener and be informed when it's called. The second thing they'll need to be able to do is unregister or remove a listener. And the final thing that we want this class to do is we want it to notify people when the data changes. So let's go ahead and create really 3 simple tests. So should add a listener, should remove a listener, and finally, should notify. Probably could have better names for these tests, but hopefully this gets the point across. So what we're going to want to do is we're just going to want to create a model, and then we're going to want to add a listener to it. So model.addListener, and we'll just provide a blank function for now, and then we'll want to say, okay, we expect our model that has listeners, and we'll want that to be true. Simple enough. Okay, so the second one will be very similar to this one. So we're going to just go ahead and create a model. Then we'll create a listener function that we can reuse, so we can add and remove the same function. So create a listener function, and this will just kind of sit there. And then we'll want to be able to add listener, and finally remove it. And then we'll expect that we don't have any listeners. So model.hasListeners is false. Okay, and then finally, we'll want to just make sure that if someone calls notify listeners, that a callback is run in response to this. So the final one, we'll just write, once again, we'll need a model. Then we'll need to add a listener. And in here, we'll provide a function that maybe just increments like a call count every time. So we'll also need to start with a call count. And then we'll do model.notifyListeners, and then we can expect that the call count has gone from 0 to 1. So this is just like a really simple way for us to verify that this function is being called, essentially. Call count is now 1. All right, so nothing's working. Our model is breaking. If we try to run these tests, we'd get a bunch of errors. So let's actually go ahead and create the model file. So we've got our model, class model. Boom. Done. All right. So now let's import that. Oh no, more breakages. Okay, so now what we'll do is I'm going to go ahead and do my lazy coding where I ask IntelliJ to generate all of these methods for me. So I'm simply going to hit Option, Enter, and I'm going to say, hey, create that method add listener. Sweet. I'm going to do the same thing for remove listener, create method. Then we're going to go ahead and have it generate has listeners for us. Okay, we're going to want this to return a Boolean. Right now it's just returning null. Cool stuff. Oh, add listener. It looks like I had a typo there. And finally, we're going to want to implement this notify listeners. So if we go ahead and create the method, it'll all be there. So now our tests look like they're no errors. And if we run it, hopefully nothing should pass. So we're doing the red-green refactor. So if you were ready to see some breaking tests live coding, we got it. All right. So then really as simple as this gets. So all we're going to do at this point is now we need to actually implement these functions. So really all we're going to do is under the hood, ScopedModel is just holding a set of listeners. So in this case, it's void functions. So we're just going to create a set and hold that. Whether or not we have any listeners, we're just going to say, is the listeners, is it not empty? When someone adds a listener, we're going to listeners.add that listener. So it's really, and I know this seems crazy, but this is all model, the model class is. It's like, it's all it is. So if we run our test at this point, we should actually have a passing test, right? So we've implemented add listener and has listeners, and look at that, we've got one passing test. So we can add a listener. Let's get remove listeners going. All right, listeners.remove. Boom. If we run our tests again, hopefully that second test should pass. All right, and then finally, we're going to go ahead and call our listeners when we notify them. So what's that going to do? We're literally just going to loop through our set of listeners, and we're going to call the listener on each iteration. So what this is doing is just looping for each listener, and then, like I said, running that callback. So when someone does this, we should be able to increment that call count, and our test should pass as well. Boom. All right. So we got our tests passing, and this is really all the model class is. And the reason I wanted to kind of start with the model class, even though it's super simple, is that it's really, I just want to kind of just draw this distinction between models and ScopedModel. And you can use model independently of the ScopedModel widget. It's just a regular class that you can extend and make use of for yourself. And the way it works is really about as simple as it gets. Now in the real implementation, there's actually just like a couple of extra things in here to like handle some edge cases. So if you like remove a listener as you're looping through, it won't break, stuff like that. But overall, this is really almost the implementation of a model class. And then this gives you the ability to write that counter like we had earlier. So if we wanted to, let's go to our main.dart. I won't test this one, let's just do it. So we want a counter, and we're going to extend model. And then we'll import that one. Oh, actually I forgot to do one interesting thing. So this is an important one. The model class, as I said, is a listenable. And right now it's not implementing that interface, but we're going to go ahead and implement that interface as well. So we'll go ahead and import Flutter Foundation, where the listenable interface is defined. And if you actually look at this one, it really only has two methods that you need to implement, the add and remove listeners. So that's why we've used those names in general. Okay. So now we have our counter, and we said we've got some internal data. We've got a count. We'll start at 0. You could maybe take a constructor parameter to set this as part of that, but we'll just start it at 0. We'll provide a public getter, so get count. We'll return the count itself, and then we'll have that increment method, which increments the count and then notifies listeners. And now we can actually use this. So I'm going to go ahead and deploy this app to my handy simulator. Looking great. All right, there we go. Oh, no, I ran the tests again. OK. So let's go ahead and run this app. And what we're going to do is we're just going to swap out the implementation that we had with a stateful widget. So this is like the default implementation you get with a Hello World app with Flutter. And we're going to swap it out for this version that uses a model. So while that's assembling, I'm going to do my favorite thing on the starter projects, which is to delete all comments, just to clean that up a little bit. All right, running task Gradle assemble debug. Come on, friend. There we go. Installing the build output. So right now, we've got our app. Like I said, this is just the default app that you get with Flutter. So it's going to have a stateful widget and a state class, and it's going to handle all this logic internally. And like as I said, if you wanted to test this logic, it's going to be a little more difficult if it's inside this state class than if it's kind of its own class. And so this is working fine right now, of course, but we're going to want to make it work with our model instead. So now what we'll do is instead of having an integer that we're storing and managing that ourselves, we're simply going to instantiate the counter. Counter equals counter. And then what we'll want to do is we'll actually want to use this counter to display the text. So in this case, we'll want to get the counter. Did I not expose that? Not count. All right. And then when someone clicks on this button, we'll call the counter.increment. So if we restart that, we're going to play it, and nothing's going to happen, right? Oh no, so what's going on? Well, the problem is that the increment count method, or the increment method, is being run, and it's notifying its listeners. But as I said, in order to listen to changes, we need to use an animated builder. So we're going to wrap this. Oh, actually, there's a new option to wrap it with a stream builder. I wonder if that'll give me an easier thing to mess with. All right, so animated builder. And then we're going to have an animation. And remember, this can actually be any listenable despite the name. And so if we look at this signature, that's tiny. But you can see that it takes any listenable. So even though, like I said, it's called the animated builder, you can totally use it with any listenable, even if it's a listenable that you create yourself, as in this case, like a counter. All right, and then the animated builder, it's going to get a second parameter that we're not going to use. And then whenever that changes, we're just going to rebuild the text. Okay, cool. So now if we save that and hot reload it, okay, 3 comes up immediately. And as we push our button, we can see that it's actually responding. Cool. All right, so the model class is done, and it's working. And so our next challenge will be to implement the scoped model part. So as I said, the whole point of the scope model part is that if you have a widget tree, and remember, you don't need to use this, like the actual scope model widget. If you just want to use the model within a single stateful widget or a single widget, that's totally fine. But if you find yourself with a more complex widget tree and you want to pass this data down the tree easily without having to do that thing like I talked about, which is called prop drilling, where you're like passing it from one constructor to another, then we can use the inherited widget, and we can create a wrapper around that that's handy, and we'll call that the scope model. So let's first make our UI a bit more complex. And I want to do that by extracting a couple of widgets. So what I want to start with is I want to extract this widget. So I'm just using Flutter's extract widget command. Unfortunately, my text is still tiny. But what I'm using is the extract widget refactoring tool that's found in like VS Code and IntelliJ. In this case, I'm using IntelliJ. And we're just going to go ahead and call this like homepage body. So what's nice about that is that Flutter, or these tools in IntelliJ are really smart, and it'll actually refactor. It'll take this code out of here. So we got my homepage, and then in the scaffold, where we used to have that big chunk of code, we've just taken that and made it its own widget. And then I'm just going to do that one more time. And this is just to kind of create a kind of a deep widget tree in a way that shows you how you might have to pass that counter down the widget tree. So let's go ahead and extract one more widget and like call it counter text. Get rid of that new keyword. And once again, the refactoring tools are really nice, and it will do that prop drilling for us. But it's still like a little bit annoying. You know, if you want to make a change to this app later, and you actually no longer need to pass this counter down, then you might have to like go through all these constructors and rip this thing back out. And so if we reload our app, I'm just going to hot restart. We should be back at 0, and everything should be working fine. But we want to do two things. First, we want to avoid passing this counter down. So let's use an inherited widget. So I'm going to use, once again, the IntelliJ or VS Code has this shortcut called INH, and if you do that and hit tab, it will actually generate some of the boilerplate for you around an inherited widget, just like as if you type like stateless, it will actually generate a stateless widget, or stateful, and it will generate a full stateful widget for you. So I'm not sure, these are just like some random tips and tricks. But yeah, I use these a lot, and if you need to create an inherited widget, this is just a nice way that comes out of the box with these tools to build it up. So let's go ahead and create like a counter. So instead of calling it scoped model, let's call it like scoped counter. And what we'll need to do is this will need to take a child, and it will also need to take in a counter, of course. So let's final counter, and required counter. Counter. All right, and then what this is actually going to do is it's also going to generate a method for us called this of method. And this is a static method, and this is generally the way you access inherited widgets. And so you might have used this in the past with things like the theme widget. And so the theme, basically, you can define a theme at the top of your app, and Flutter will use an inherited widget to pass that theme down through your app. And so you can use things like theme.of to grab your app-wide theme. And this is exactly the same thing that we're doing here. And what this will do is this will actually use the build context, and it'll use a method from that build context, which will actually perform this lookup for you. So it will say, hey, given the current build context, please look up the widget tree for the specific inherited widget that I'm interested in. And then we'll go ahead and just cast it as a counter. Just to make this a little simpler, we'll actually want to return a counter from here. So let's go ahead and just, so we're going to look up the widget tree for this scoped counter, and we're just going to return the counter from it. And finally, what we'll need to do is we need to implement this update ShouldNotify method. Now, one of the really cool things about inherited widgets that's a little confusing when you first find them is that if an inherited widget is rebuilt, it will actually run this update ShouldNotify method. And if this method returns true, then any of the widgets that are referencing this via like the ScopedModel or ScopedCounter.of will actually know, hey, something has changed. This has told me that it should rebuild, and so I'll rebuild myself. And so this is a really nice way to not only pass data down the tree, but you can actually have those widgets automatically rebuild when that data changes. Now in our case, I'm just going to be lazy and say return true. If you had a more complex case, you could maybe try to optimize this. So like you would only rebuild those widgets when like a certain condition is met. In this case, we'll just say anytime this model changes, let's just rebuild it. Cool. So then what we're going to need to do is we're going to need to get access to the counter. So how do we do that? So in this case, what we'll do is we'll just wrap the homepage body with a new widget, and we'll wrap it with that scoped counter. And that's going to tell me that I need to add the counter requirement as well. Okay, cool. So then what we can do is we can actually access this counter from our counter text widget within the build method. So now we can say final counter equals scoped counter.of context. And then rather than using this counter, we're just going to use the counter we found. So rather than using the counter that's passed to this widget, we're going to use the counter that we found via the context. And this, hopefully, if we just save that, that will all work. Woohoo! All right, so we're looking good. Now what we can do is we can actually just rip this stuff out of here. So we don't need to pass that down anymore. We don't need to pass this through here. We don't need to pass it to this widget, which is the homepage body anymore. All right, and everything should be working. So let's just restart to make sure that's the case. Awesome. All right, and the other thing is, oops, that's not the window I wanted. The other thing we can do is we can actually look at the performance tools as well. So if we look at Flutter performance, we can look at this, these redraws, and we can see that when you tap this button, the only things that are actually being rebuilt are the text and the animated builder. So this is great. But it's a little bit interesting, right? Because I said when you use inherited widgets, you can actually have them do some automatic rebuilding for you. So in this case, we're just handing down the counter, and anyone who wants to use this counter would actually have to subscribe or listen to it with an animated builder. But we can actually make this process automatic as well. So what we're going to do instead is we're going to move that animated counter to a different place, or the animated builder to a different place. So let's go ahead and try doing that. So in this case, we actually we need a little bit more than just an inherited widget. We'll actually need our own stateless widget. And I'm actually just going to go ahead and rename this real quick and call it like inherited counter. And then we'll create a new class called scoped counter. And it will basically have the same interface as the previous one, but it will actually it'll have a little trick in there as well. So we're going to take in the counter. And, oh, sorry, this extends stateless widget. Override. And we'll need a build method, and we'll need a constructor for that. And of course, just like the inherited widget, we'll need to be able to take in a child as well. All right. So now this one will actually do the animated builder at this point. So animation will be the counter again. And now whenever this one builds, what we're going to do is we're going to run the builder. And we don't need that second param. In this case, we're just going to create an inherited counter. And this will take in the counter. Okay, cool. Perfect. Yeah, so we've got errors. So the other thing we're going to want to do is we're going to want to move this of method. Just because it's a little nicer on the scope model, we'll move it there instead. Let's see, do I have any? Oh no. Isn't defined for inherited counter. Scoped counter. Let's try to rebuild one more time. Uh-oh, do not throw. Beautiful. All right, nothing happened. All right, and so now we're working. But the funny thing is, now what we're doing is instead of, now what's funny is we're still building this counter text twice. And so what we can do is we can actually remove this. And it seems crazy, but this should actually continue to rebuild whenever the counter is clicked. So what's happening here? So what's happening is that we've got a scoped counter. As I said, it's actually going to rebuild this inherited counter whenever the counter changes. And this is kind of an interesting tidbit, like I said, in that whenever this thing is rebuilt, anything that's referencing it via this of method, where'd that go? Anyways, I'm losing myself. Via this of method will be rebuilt automatically as well. So this is like part of the power of inherited widgets, and it's really cool. And what it means is that you could actually have, like, if you wanted to use multiple maybe different models in this type of thing, you could actually say like user equals like scoped user of context. And once again, that should be doing the exact same thing. And so you can actually rely on multiple models from within a build function, and it would be automatically rebuilt for you. And like I said, it's nice that inherited widgets do this, and this is exactly the type of thing that ScopedModel takes advantage of. But you can do this with anything, right? You could do this with your own data. You could do this with like a stream, for example. You know, you could put a stream builder in an inherited widget and pass that down as well. My hot reload has been having some issues, unfortunately, the last couple of days, so I had to stop and redeploy. But we'll be back up in a second. So we've got this of method now. And the final thing is, you might be wondering, okay, so where does the ScopedModel descendant come in? Well, really the reason that we're kind of using this counter text is so that we're not rebuilding a large part of the widget tree. Now, whenever you use this thing, so we could actually, for example, move this text back up here. Actually, let's just do this real quick. I think it might be interesting. So if we see it right now and we do a click, we'll notice, oh no. Looks like everything's rebuilding. All right, I'm not sure that's accurate. I've had some weird issues with this in the past, so I think I'm just gonna skip this part for now. I might have made a mistake as well. Probably made a mistake if we're gonna go with that, so I'm just gonna skip it. But basically what should be happening is that only this text widget should be rebuilt at this point. So the nice thing about this The problem is though, like we don't always want to like create a separate widget to like reduce the amount of drawing. So what you can do is you can also create another stateless widget, and we'll call this scoped counter descendant. And what it will do is this component will look for the counter using the scoped counter. No. And then it will take in a builder function that you provide. So this will just be a function that returns a widget and is passed a context and a listenable, basically. So build context listenable. Actually, sorry, it'll just be the counter. My bad. And we'll call this the builder. So we'll want to take that in as a constructor field. And then all we'll do is we'll say, OK, every time this model changes, we'll want to run this builder function. So just return the builder with the context and the counter. And so this is nice because now we actually, if we wanted to like make the re-rendering a bit less, if we wanted to restrict the rendering to only this text widget and still pull it from the current context, we don't need to actually have a separate widget for this anymore. We could just use that scoped counter descendant. And then the builder it's going to take context counter, and it's just going to return that counter text. And so this should act as a perfectly good substitute for what we had previously without you having to kind of create your own widget. Works like a charm. All right, what did I do wrong here? Counter scope model. Let's see here. What have I done? It just worked. Now it doesn't. Anyways, that's a bummer. What is going on? I don't know if I want to live debug this. I'm not exactly sure. I probably have a simple bug somewhere. But this is really generally the concept that you're going to be working with is like the counter. So if you worked with like a scope model and a scope model descendant, it's really just sort of getting the reference to this counter for you or this model for you and passing it into a builder function so that you don't have to sort of split your widgets out a bit. All right. So that kind of concludes the coding portion. I'm really bummed it ended on a fail at the very last moment, but we almost got there. Gods are fickle, so they didn't let us get all the way there. So yeah, that might have been a lot, but hopefully what you've seen is that the model class is actually nothing crazy. Oh, actually, I really wanted to make one more point, is that the model class actually isn't even necessary anymore. So there's actually a class called ShouldNotify that comes with Flutter, and it actually does all of this stuff out of the box. So when model class was first created by the Fuchsia team, I believe that the change notifier wasn't in the Flutter code base, and then it was added to the Flutter code base. And so at this point, the model class is actually not even really necessary anymore. So you can just use the tools that Flutter provides out of the box, and they work in the exact same way. And you can even just go look at this class once again. You can see it implements the Listenable interface. So it's got a has listeners method. It's actually, it's really well tested on their side. It's got some of the extra checks, like I mentioned, for safety. If like you remove a listener or a listener throws an error, it'll handle that kind of stuff properly. So you don't even need the model class anymore. And you could basically just use change notifier. So really at that point, then you might be wondering, well, what's the point of scope model? Then it might provide exactly one class, the ScopedModel Widget. And so what we're talking about is there's another project called the Provider package, and that's from Remy Resselet. I'm so sorry, bud. I probably messed your name up. I swear to God, I'm sorry. And so this is a package that allows you to provide anything down the widget tree. And one of the providers that it has is something called a change notifier provider. And that works in the exact same way that we just saw as like the scoped counter does. And it just works on any type of change notifier. So we might be merging those two projects together because some of this functionality now comes out of the box with Flutter. And because I think the name Scope Model and Scope Model Descendant is a bit of a mouthful, and I think provider and consumer are shorter and better. So, and the API is just nicer and a little more abstract. So it allows you to actually not only provide change notifiers, but if you just want to provide some other random data down the tree, it'll allow you to do that as well. in a really simple fashion. So hopefully that kind of gave you an overview, a very quick overview of how ScopedModel works, how the of function is actually working underneath the hood, which is that it is going to subscribe the entire build context to that animated builder up the tree, and whenever that animated builder rebuilds the inherited widget, it will be rebuilt itself. If you want to use multiple models from within a build method, you can totally do that. And if you want to optimize your rendering, then what you can do is you can consider using something like the ScopedModel descendant to rebuild a smaller portion of your widget tree. So these are sort of the things I was really hoping you'd kind of get out of this. So yeah, thank you so much, and yeah, happy to take questions. Oh yeah.
Hi.
Hey.
I was just curious, when you did the line where you did your lookup back up the tree and you did your type assertion, is that like an optional, or is Flutter going to handle that?
Oh yeah. So you're talking about like the of method, where I was like, get this thing and then cast it and then like get it again and then cast it again.
Isn't that unsafe?
It's the only area. It's one of the few areas like I really wish this inherit widget from exact type was parameterized instead of taking a type. I kind of wish it like you. Yeah.
Because what if that counter doesn't exist in the given tree and you put that widget there and it'll bail out when it's run, but will it bail out at compile time where you want it? Like,
absolutely not.
Yeah.
Yeah. No. I mean, that's an interesting question. Like, it would be awesome if that could be compile safe. My method
Can
for
I
handling,
say it's optional and deal with it optionally? Like, is there a way to do that?
My method, at least personally, is maybe once we have maybe like null safe operators or something, like we could do that. My current approach is to fail fast. So if there's no model in the tree, throw an error. And that way, if this problem were to somehow crop up in the wild, hopefully you've got something like Crashalytics in your app. You would see an error, and you'd see like, oh my gosh, on main or on like homepage line 34, we're trying to access this model and it's not working. And I've also got some like really clear like, this is step 1 to fix it. This is step 2 to fix it.
Well,
so,
naturally, you could just do a conditional in there and just say like, if I look up, like if it's there, like don't execute. Or I think that requires you to return something, right?
Yeah, I mean, well, you could return null. You can always return null, but just in my opinion, like working on large apps, it's much better to throw the null pointer exception here than to like return null and then have everyone deal with like, if it's null, I don't know what to do at this point. Because it's much better to get an error report, fix that error report, and move on than it is to like, I don't know, in this one weird portion of my app, my user's telling me that like they're not getting any responses, and that's just impossible.
Definitely like throw something like so you can fix it for sure. But that was my only question, because that's typically something that I want
for sure.
To be notified at compile time that but I guess you don't know. I guess the compiler won't know if the whole state of the tree until you actually run it.
Exactly. Yeah. You'd have to do. It'd be interesting. You'd have to do some analysis of like so yeah, it'd be interesting.
My other question, sorry, I have two.
Oh, no worries.
So it's cool that you want to split out like re-rendering into separate models. Like if you have a huge tree and you have lots of updates happening and a big data set, you want to have like appropriate separation of concerns and appropriate re-rendering based on that. Do you think there's an easy way to incorporate some form of memoization possibly to help that process along performance-wise?
Depends like what kind of memoization you want. I mean,
so naturally, if you have a large model and it has an observer on or a listenable, for example, like anytime that large model gets updated, it's going to propagate those changes down the tree.
Yes.
And anyone listening is going to run an update on that. And in some cases, the data hasn't changed, and you don't want to do a re-render.
Yep. Fair point.
Does that hit a virtual like analysis, a virtual diff on Flutter's end, or is there some kind of data shallow diff you can do on your end to optimize that further?
With the model class, there's not as much you can do because you can't really compare the old instance to the new instance because it's the same instance. And so you'd be like, is my like old counter the same as my new counter? It's gonna be like, yeah, it is, bro, because it's the same thing. Whereas like with like a stream-based thing, like you might be able to deliver like one counter and then another counter and like do some comparison on that.
I mean, if you separate it properly, that's less of a concern. But in some cases, you have a large model and a lot of listeners, then it starts becoming a rendering problem. And it's a problem I've dealt with in React Native, for example.
Sure.
Then React Memo, for example, a new feature coming in, is really helpful in that regard, especially when you're dealing with pure functional components. But I was just wondering if there's some level of equivalency there.
Yeah, I mean, I think the whole thing is there's a really interesting trade-off, right? So you can totally do that, right? And so rather than having your whole class be a listenable, you could make individual things listenables, right?
Yeah.
So in this case, you can actually use something called a value notifier, I would just use a value notifier, and basically that is, then your class would be composed of different value notifiers, and then you could pass the model down, but in that case you'd have to use animated builders to like listen to each of those individually. And this is essentially the exact same way that like the block pattern works. It kind of exposes a series of streams rather than exposing one single stream. And there's pros and cons to this. So the pro is that you're going to get better re-rendering, faster re-rendering, because you'll have fewer widgets re-rendering in response to changes. The downside is that it's usually slightly more complex, right? So if you need to respond to two different things, in this case, you can just like notify dataset changed, and you can provide like a getter if you had like a login page, like is the email valid and is the password valid, then login button enabled. Whereas if like each of those things were their own listenable, then you might need to do like a little more coordination in that case. And so this is where I think like there's a new MobX.Dart library, and it's trying to aim to help out with some of these types of things, using kind of code generation to sort of take care of a lot of that boilerplate for you.
I do like the simplicity and the level of control you get with this approach, so I like it.
Yeah, yeah, and I think that's what people generally like about scope models. It's just like, you just increment a counter, dude. It's not magic, so yeah. So yeah, I think that's a really great question, and it's a classic trade-off of it's simpler to have one observable. If you find yourself having performance issues, you might want to refactor to multiple listenables instead. Yep. Or maybe think if that class might be too big and split apart.
Memoization can't help if you don't want to refactor.
Exactly, and like as always, if you need memoization, just use a const widget, and it will help out a lot. So yeah, for sure.
All right, I'm going to have to call it on Q&A for now.
Oh, okay.
We will carry on afterwards. We've got food outside, so let's go and have a quick break, like a 15-20 minute break, and we'll continue with Frederick, and we'll continue with Q&A after as well, if you like, or even down the pub.
All right, sounds good.